Okay, so here's our lesson about equations of circles. And I'll be honest with you, I think equations of circles are super fun. They're super easy. There's not a whole lot to a circle, so I think that's what makes them pretty simple. And what's even more fun is they look complicated, so it looks like you're doing really difficult things when really you aren't. All right, so the first thing we need to go ahead and write down is our definition of a circle, because that's going to be important for how we write the equation. So a circle can be defined as a set of all points that are a fixed distance from the center. So, right, if we have a certain point in the center, that fixed distance that we're talking about is the radius. Okay, so to figure out this equation, they've gone ahead and they've given us a circle drawn with a point on it. Okay, so when we think about distance, we want to think about how distance, we've found that before using the distance formula, and you all know I don't like the distance formula. I prefer to just use Pythagorean theorem. And so we do that. We're trying to find a way to write the distance between some unknown points. So notice that they have this center point here with coordinates h and k. They've got a point that's on the circle, and that this could be any point on the circle, so they're just going to call it x and y. And then we've got the radius, which is measured here in r. So we know the radius is the distance. And again, I'm just repeating myself, distance is Pythagorean theorem. So we want to figure out how far apart, if you remember this, we pair these two together, x and h, and we want to find how far apart those are. So to find the distance between any two things, we normally just subtract, right? Think about a number line. How far apart are, I'm just picking arbitrary numbers, how far apart are 3 and 10? Well, they're 7 spaces apart because 10 minus 3 equals 7. So since I don't know what these are, but I know I need to find the distance between them, I'm going to call that x minus h. And we're doing Pythagorean theorem, so that's squared. All right, and then I'm going to pair my y values together. And I don't actually have anything to subtract, but I can represent that as, so that's a squared plus b squared, which is going to be y minus k squared. And all of that will equal the c squared, or the distance. And in this case, distance is defined as the radius for a circle. Remember, Pythagorean theorem says, because I've got to fix this, a squared plus b squared equals c squared. So I've got this a squared plus b squared equals c squared, so our radius squared. So there is your formula for a circle. That's how we write all the equations of circles. And we just need to talk about what those things mean. So in your notes, you just need to remind yourself that HK was the center of the circle. Notice that inside the formula, it looks opposite of what you think. So if H is at 7 in this formula, it's going to read X minus 7. So it's going to say positive 7, but look like negative 7 in the formula. All right. And then R is the radius. And we haven't really defined x and y. Normally, x and y are going to stay in your equation, but x and y are defined as a point on the circle. So let's see some problems that we can solve using this information. All right, we're going to look at these 3 problems really quickly. So remember, we said that whatever ends up being inside as part of the center of the circle ends up looking opposite because it's x minus h and y minus k. So for instance, the center here, these are your h and k. So it's going to look like x plus 2, because it's opposite, squared, plus y minus 5, because it's opposite, squared, equals the radius squared. And instead of writing 3 squared, it's probably, well, it is better for you to write 9. All right, so that right there is the equation of this circle. All right, if I work out this next one, my first one is going to be x minus 4 squared, because I'm doing opposite, plus y plus 1 squared equals, now on this last part, the radius squared is the square root of 5 squared, and remember, square root and squared are going to cancel each other out, so that's just going to equal the whole number 5. All right, so there's our equation for that one. This last question at the bottom is going to ask, it's really only asking one thing, but I'm going to add an additional component to that just because I want to make sure that you understand. So this question at the bottom Sorry, clearly struggling with technology. This question at the bottom, the first thing I want to ask before we even talk about the translation of the circle is just what does this information give me to begin with? So in this original equation, I have a center that's at, think opposite because we're inside parentheses here. I have a center that's at 2, -4, and I have a radius. Remember, the other side of the square root that's like radius squared. So the actual radius is the length square root of 7. Okay, so now what this question is actually asking is if we translate that using this transformation, what will the equation of the image of the circle be? So remember transformations, when we add or subtract, all we're doing is a translation, shifting left, right, up, or down. So this +3 is going to move us right 3, and the -1 is going to move us down 1. So we need to think about those transformations on our center. That means our new center is going to be at, if we shifted, let's see, right 3, that's going to put me at 5 and at -5. All right, notice I'm using these coordinates that I wrote, not the original equation. So I've shifted the center there. And just because I've translated it doesn't mean I've changed the size of the circle. So the radius should still be the square root of 7. So when I go ahead and write this equation, my new equation is going to be x minus 5 squared plus y plus 5 squared equals 7, because the square root of 7 squared is just the whole number 7. Now, there is a way for you to have done that without having to name the center and the radius from the original equation, but I think that kind of gets confusing, and that, to me, it makes more sense to name the center and the radius first, and then apply the transformations once you've identified what they are. Okay, so this is going to add a little bit of length to our video. I'm sorry. I'm going to try to explain it really quickly, and I can go in depth tomorrow about where this is coming from, but I just want to show you real quick about how to rewrite an equation and then actually to graph a circle. So notice that in A, this is not the form that I want. I've got x squared and an x, a y squared and a y. I don't have any parentheses, right? We know we're supposed to have parentheses there, so we need to talk about how to fix that. So what we're going to do is called completing the square. And you may have seen this in Algebra 1 last year in 8th grade. You may not have, I don't know. So let me just show you the quick method, and then I'll explain where it's all coming from. So the first thing we want to do is kind of regroup our variables. So I've got x squareds, and then I'm going to put a blank in there, plus y squared plus 2y with a blank equals 20. All right, and the idea is I'm grouping like the x's together and then the y's together. So to complete the square, we're going to take half of this middle number and then square it. So half of -4 is -2. -2 squared is 4. So what that's going to allow us to do is to write this as x minus 2 squared. All right, notice I took half of that -4 and it became -2. Okay, I'm going to repeat that process, and you can rewatch this part of the video if you need to. So I'm going to take half of this middle number, which is 1, so that means my parentheses are going to become y plus 1, and then I'm going to square that number to get this outside number. 1 squared is still 1. Now, notice that I've added a 4 and a 1 on this left side of the equation. I can't just add those in there because I want to, so I have to add +4 and +1 on the right side of the equation, right? What you do to one side, you have to do to the other. So that's going to make our final equation x minus 2 squared plus y plus 1 squared equals 20 plus 4 plus 1 is 25. All right, so I did all that just to rewrite my equation. Now that I've done that, that should be pretty simple for me to actually answer the important parts that I need. From that form, I can tell that the center is going to be at 2, -1, and that the radius is going to be the square root of 25, or just 5. All right, the last part about this is just to graph the circle, and I think this part you can do pretty easily, even if you weren't sure on that first step. So I know that the center is at 2, -1, so I'm going to graph that, 2, -1. And my radius is 5, which means that's the distance all the way around. So I'm just going to count 5 in every direction there. So I'm going to go going up 5, down 5. I'm really just trying to find points that are on here. To the right 5, to the left 5, which kind of goes off. And then this is not going to be perfect, but I'm just going to kind of draw the best little looking circle that I can. Wow. Hopefully yours is not as terrible as that is. So, like I said, rewatch this part about completing the square if you need to. We'll do some more examples on that tomorrow, but those are the basics of what you need to know for equations of a circle.